Hello everyone, this is Hymavathi, working as an assistant professor in the Department of Humanities and Science, MLR Institute of Technology. So in the last sessions, we have seen how to find the solution of homogeneous differential equations with constant coefficients. And also we have seen how to find the complementary function also. And in this session, so we are going to discuss about the solution of finding non-homogeneous linear differential equation with the constant coefficient and how to find the particular integral of type 1, and we'll do the problems on this type 1. The next, how to find the general solution of non-homogeneous differential equations. So what is the form of non-homogeneous differential equations? The form of non-homogeneous differential equations are f of d into y is equal to q of x or f of x or capital X. So these are the forms, and this is the form of given non-homogeneous linear differential equation with the constant coefficients. The general solution of f of d into y is equal to q of x is y is equal to yc plus yp, where yc is nothing but particular integral and yc is nothing but a complementary function. So already we have seen how to find the complementary function in the previous session, and now we'll see how to find the particular integral. So now let us see what's a defined particular integral. The particular integral is the evaluation of 1 by f of d into q of x, is known as a particular integral and is denoted by yp, where yp is 1 by f of d into q of x. So what is the particular integral defines? 1 by f of d into q of x or f of x or capital X. So q of x and f of x are the functions of x. So here we have the different functions are there. For different functions we have the different process to find the particular integral. Now let us see then how to find the particular integral type 1. So what's the type 1 we are taking? Here the type 1 is when f of x is equal to e power ax or q of x is equal to e power ax. When the function is e power ax, then to find the yp, 1 by f of d into q of x or f of x is equal to 1 by f of d into q of x or f of x is nothing but e power ax. Then to find the yp, you just substitute d by a in the denominator, that is f of a into e power ax. So where f of a not equal to 0, where f of a not equal to 0, then we can say 1 by f of a into e power ax is a particular integral of f of d into y is equal to e power ax. Then sometimes the denominator gives the 0. That means sometimes f of a is equal to 0 exists. If 0 exists, then how can we find the particular integral? To find the particular integral, x into 1 by f dash of d into e power ax. So what is nothing but f dash of d? This means derivative of f of d with respect to d. Then later you have to substitute d by a, then this gives the particular integral of the given function. Sometimes f dash of a is equal to 0 exists, and then later again you have to do the differentiation, and again you have to multiply with one more x. So by multiplying with the x square into 1 by f double dash of a into e power ax. So this is the yp only when f double dash of a is not equal to 0. So continue this procedure until getting the denominator is not equal to 0 by multiplying with the x. So this is the way to find the particular integral when q of x is equal to e power ax. Then now let us see one example or one problem on this process. So see the first problem. Solve d square plus 2d plus 1 into y is equal to e power minus x. So now this is of the form f of d into y is equal to q of x or f of x. And this differential equations is nothing but non-homogeneous linear differential equation with the constant coefficients. Then what is the solution of this differential equation? Y is equal to complementary function plus particular integral. So now first you have to find the complementary function of the given differential equations. How can we find the particular integral and a complementary function? So to find the complementary function, the first you have to take the auxiliary equation. So what is the auxiliary equation? So the auxiliary equation is nothing but algebraic equation of f of m is equal to 0. So we have f of d. So what is f of d from the given differential equation? D square plus 2d plus 1. Then now you have to replace d by m and equate it to 0. F of m is equal to m square plus 2m plus 1 is equal to 0. By equating to 0 here, definitely we will get the roots of this differential equation and roots of this equation. So what is the roots of this equation? M is equal to 1 comma 1. That means this equation can be written as m plus 1 whole square is equal to 0. M plus 1 whole square is equal to 0. That means here the roots are m is equal to minus 1 comma minus 1. So these are the roots of this equation f of m is equal to 0. So here minus 1 are the real and repeated root. If it is the real and repeated root, then to write the complementary function yc is equal to c1 plus c2x into e power minus x. So this is the complementary function when the roots are repeated twice. And next to find the particular integral. So to find the particular integral, we have the formula is there. So what is that formula is 1 by f of d into q of x is the formula of yp. So now here you have to substitute what is f of d, d square plus 2d plus 1. When the q of x is, the given q of x is e power minus x. Right? So here what is the substitution to take? The substitution is d by a. So here what is the a value? Minus 1 here. So substitute d by minus 1 here. So 1 by minus 1 whole square plus 2 into minus 1 plus 1 into e power minus x. So this is equal to, then now you have to do the simplification in the denominator whether that value is giving 0 or not equal to 0. So if it is not equal to 0, we can take that value is an yp. If we are getting the 0, we have to do the differentiation. So minus 1 whole square is 1, minus 2 plus 1 into e power minus x. So now here in the denominator, it gives the 0, so that we have to do the differentiation and by multiplying with the x. So here this gives the 0, so that you have to multiply with the x into 1 by the derivative we have to find out on f of d with respect to d. So this is f of d. The derivative of d square plus 2d plus 1 is 2d plus 2 is the differentiation into e power minus x. And now again you have to substitute d by minus 1. So 1 by 2 into minus 1 plus 2 into e power minus x. So now again we have to cross check whether the denominator value is 0 or non-zero. So clearly we know that this value is 0 again. So that again you have to multiply with the x square and again you have to differentiate on f dash of d. So f dash of d is 2d plus 2. Again the differentiation is only 2 into e power minus x. So in the denominator, see the denominator value is not equal to 0 here. So that x square by 2 into e power minus x is the yp value. Then finally, write the general solution. The general solution of non-homogeneous linear differential equations with constant coefficients is y is equal to yc plus yp. So what is the yc? yc is c1 plus c2x into e power minus x plus this is the yp, x squared by 2 into e power minus x. So this is the general solution of the given differential equations. So now let's see the other problem. So this is the next problem. D cube minus 6d square plus 11d minus 6 into y is equal to e power minus 2x plus e power minus 3x. So now we will see the solution of this differential equation. So second one is d cube minus 6d square plus 11d minus 6 into y is equal to e power minus 2x plus e power minus 3x. So this is of the form non-homogeneous linear differential equation with constant coefficients. So the general solution of this differential equation is the complementary function plus a particular integral. So first we have to find the complementary function. So to find the complementary function, so you have to write the auxiliary equation. The auxiliary equation is nothing but the algebraic equation of f of m is equal to 0. So we know that what is f of d. So this is the f of d. In this f of d we have to substitute d is equal to m. So m cube minus 6m square plus 11m minus 6 is equal to 0. Then now this is the third order equation. So definitely it will give the 3 roots. So what are the 3 roots of this equation? So m is equal to 1, 2, 3 are the roots of this equation. Or this can also be taken as m minus 1 into m square minus 5m plus 6 is equal to 0. So m cube minus 6m square plus 11m minus 6 is equal to 0 can also be written as m minus 1 into m square minus 5m plus 6 is equal to 0. So now the roots are m is equal to 1, 2, 3. So this m square minus 5m plus 6 is nothing but m minus 2 into m minus 3. So that the roots are m is equal to 1, 2, 3. So now you have to write the complementary function. That complementary function is denoted by yc. So to write the yc, so first observe the roots. So here the roots are real root and these roots are not repeated. If it is not repeated, then the complementary function is c1 e power x plus c2 e power 2x plus c3 e power 3x. This is the complementary function for non-repeated roots. And now to find the yp. Next to find the yp. So to find the yp defines yp is equal to 1 by f of d into q of x or f of x. So here the q of x is nothing but e power minus 2x plus e power minus 3x. So now take the f of d here. D cube minus 6d square plus 11d minus 6. Q of x is nothing but e power minus 2x plus e power minus 3x. And now we have to split and then we have to find the yp. 1 by d cube minus 6d square plus 11d minus 6 into e power minus 2x plus 1 by d cube minus 6d square plus 11d minus 6 into e power minus 3x. And in the first term, the substitution of the d is nothing but minus 2. In the second term, the substitution of d is minus 3. Substitute d is equal to minus 2 in the first term and substitute d is equal to minus 3 in the second term. So 1 by minus 2 whole cube minus 6 into minus 2 whole square plus 11 into minus 2 minus 6 into e power minus 2x plus 1 by minus 3 whole cube minus 6 into minus 3 whole square plus 11 into minus 3 minus 6 into e power minus 3x. So now we have to do the simplification. So whether here the denominator value is getting 0 or non-zero, we have to find out. So here, so clearly the denominator value is not equal to 0 after the simplification. So it will give e power minus 2x by minus 60 plus the next value is e power minus 3x by minus 120. So here the denominator value after the simplification, so we will get minus 60, and coming to the second term by doing the simplification here, so it will give the minus 120. So here we are not getting any 0 in the denominator, so that this is the yp of the given differential equations. So now write the general solution. The general solution is y is equal to yc plus yp. So what is the yc? So yc is c1 e power x plus c2 e power 2x plus c3 e power 3x minus e power minus 2x by 60 minus e power minus 3x by 120. So this is the general solution of the given differential equations. So this is the way to find the general solution of linear differential equations which is non-homogeneous and with constant coefficients. So then today in this session we discussed about the type 1 of particular integral. So that type 1 is q of x is equal to e power ax or f of x is equal to e power ax. So what's the general solution of non-homogeneous linear differential equation with the constant coefficients is y is equal to yc plus yp. So yc plus yp, yc is a complementary function. So this is the complementary function and yp is nothing but a particular integral. So in the next session, we will see how to find the particular integral of type 2. Thank you.